Hello everyone, I am Kausal Patel from Mechanical Engineering Department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. In this video, we are going to study Introduction to the Vibration. So some of the topics would be discussed here, that is Introduction to the Vibration, the phenomena of vibration, then causes of vibrations, undesirable effects of vibrations, methods by which we can reduce these undesirable effects of vibration, then the desirable effects of vibration and its application. Then we have also discussed in this video about the terms which are important for the study of vibration. It includes periodic motion, simple harmonic motion, periodic time, frequency, free vibration, forced vibration, natural frequency, then resonance, modes of vibration, and finally degree of freedom. Okay, so what is vibration that we are going to study here? So whenever any elastic body is displaced from its mean equilibrium position by the application of external forces and then released, it commences a cyclic motion. Such cyclic motion of a body due to the elastic property is known as vibration. Now that cyclic motion, that is nothing but to and fro motion about the mean equilibrium position. Okay, so all bodies possessing mass and elasticity are capable of vibration. So here two properties, mass and elasticity, that is most important for the vibration. It is because of that, due to the mass property, any system is having its potential energy depending on the position and condition. Okay, that potential energy could be converted into kinetic energy so that the system would be in motion. So whenever we are going to deflect certain elastic body under the elastic limit, so the work is done on that system, and that work has to be stored in some kind of energy, that is nothing but the strain energy of the body. It is due to the elastic property, and that strain energy, it is nothing but one kind of potential energy, or we can say internal energy. So this energy could also be converted into kinetic energy to get the motion. So these two properties are more important related to vibration. Now the phenomena of vibration. So to understand the phenomena of vibration, we are going to take a simple spring mass system. So here we can see that a mass is suspended by the spring at one end, and other end of spring is fixed. So initially spring would be deflected through the static deflection. Okay, and in this condition the system would be in static equilibrium, because in this condition the mass is subjected to two forces. First one, that is weight, it is acting in downward direction, and second one, that is spring force, that is acting in upward direction. So both forces are going to balance each other. Okay, so in that case the system is not in motion, it means its velocity is zero, and it remains zero under the action of this spring force and weight. So we can say that the system is in static equilibrium. Okay, now by applying some external force, we are going to deflect the system from its mean position up to certain distance. Okay, so whenever we are going to apply this external force, this mass is going to be deflected this much. So again we have done some work on the system, and that work has to be stored in some kind of energy. So that is due to this deflection. Okay, so at this lower extreme position, the strain energy of the system would be maximum. Now when the external force is removed, the internal elastic forces cause the body to restore to its initial equilibrium position. So whenever we are going to release the body, what is going to happen? This mass is going to be accelerated toward mean position. So here, on releasing the body, the strain energy is converted into kinetic energy, and body starts accelerating toward the mean position. Okay, now if there is no energy lost during this vibration, it means no damping is provided, then the whole strain energy is converted into kinetic energy by the time the system reaches the mean equilibrium position. Now at mean equilibrium position, the system is having maximum kinetic energy. It means its velocity would get maximum until it reaches the equilibrium position from the lower extreme position. So here at this mean equilibrium position, the body is having maximum velocity, and it is not going to stop here. It continue its motion in the other direction. Okay, so again spring is going to get compressed, but okay, so during that motion, the kinetic energy is converted into the strain energy of spring. Okay, and finally the velocity would be decreasing. Okay, and at upper extreme position, the whole kinetic energy is converted into strain energy if there is no loss of energy. Okay, and at this upper extreme position, the velocity would be 0. Now again strain energy is converted into kinetic energy, and it tends to accelerate the body toward a mean equilibrium condition. So this cycle repeats infinitely. That phenomena is vibration. It is nothing but to and fro motion about this mean equilibrium position, and that is longitudinal vibration for this particular case. Okay, now there are many causes of vibration. The main cause of vibration, that is unbalanced forces and couples in the machine parts. Now we already know that every machine mechanism is made of number of components which are interconnected together, that is unbalanced force. That unbalanced force leads to the vibration. Okay, so to avoid vibration, we need to balance these unbalanced forces. Okay, next cause, it is due to external excitation force. Here, whenever a system is subjected to the excitation force which is applied externally, then it could also leads to the vibration. Okay, next one, that is dry friction between two mating surfaces. Okay, so now there are many components in machinery which are having a relatively sliding motion. They are going to rub against each other, and depending on the surface roughness, dry friction would be there, and due to dry friction, it leads to vibration. So that is another cause of vibration due to dry friction between two mating surfaces. Okay, this kind of vibration is also known as self-excited vibration. Okay, so that is another important term, that is self-excited vibration. It is due to dry friction between two mating surfaces. Okay, now next one, that is winds. Now there are many systems like telephone lines, transmission line, bridges, so which are affected by the winds. The track force due to wind, it could affect this type of system, and it could leads to vibration of this kind of system. Next one, that is due to earthquake. We all know that what are the effects of earthquake on the structures like building, dams, bridges. Okay, so earthquakes also leads to the vibration. So these are the causes of vibration. Now vibration is generally not desirable. So what are the undesirable effects of vibration that we are going to discuss here? First one, that is it creates excessive stress in machine parts. Okay, that is not desirable obviously, because it could even leads to failure, or due to the excessive stress we can say the efficiency of machine and its life cycle is also greatly reduced. Next one, that is it could leads to loosening of parts. Okay, so machineries, mechanisms, they are interconnected together by different types of joints. Different types of fabrication techniques are used: bolted joints, riveted joints, welded joints. Okay, so due to the vibration, the assembled parts can be loosened. Okay, like bolt could be loosened. Okay, and it could leads to the failure. It could we can say it could leads to the hazardous situation. Okay, so that is not desirable. Next one, it may lead to partial or complete failure of machine part. Already we have discussed earlier, due to the excessive stresses. Then next one, that is it creates undesirable noise. Now noise is also not desirable. Okay, so besides this, another undesirable effect of vibration, that is due to the vibration, the efficiency of machine is going to be reduced because of the energy losses during the vibration. Okay, so these are the undesirable effects of vibration. Now we need to reduce the effect of vibration. Okay, so there are some certain methods used to reduce the effects of vibration. So first one, by removing the unbalanced force or couples in machine part which causes the vibration. Okay, for this we can use balancing methods. By balancing the system, we can reduce completely or partially the unbalanced forces and couples. So by using balancing method, we can reduce the effect of vibration. Next one, that is by placing machinery on proper type of vibration isolators. So by using vibration isolators, we can avoid the transmission of forces from machine to the foundation or other supporting structures. So that's how we can avoid failure of the system, and we can avoid the undesirable effects of vibration. So for vibration isolators, we can use rubber, felt, cork, or we can even use metallic springs. Okay, that part we are going to discuss later. Okay, next one, that is by putting the soundproof screen or glass if noise is objectionable, right? So due to reduce the undesirable noise, we can put this kind of objects like soundproof screens and glass. Okay, next one, that is by using shock absorber. We all know the application of shock absorbers that are in automobile, right? So by providing shock absorbers or other kind of dampers, we can reduce the amplitude of vibration. We can absorb the energy of vibration, and that's how we can control the vibration. So these are the methods by using which we can reduce the effect of vibration, which is undesirable. Now it is not necessary that all the effects of vibration are undesirable. Some effects of vibrations are desirable in some particular application. So first of all, we already know that without vibration, the propagation of sound in particular medium, it is not possible. So for communication, vibrations are essential, right? So acoustic vibrations are necessary in musical instruments to create music. Okay, next one, that is in certain industrial purpose, vibrating screens, shakers and vibrating conveyors are often used for different applications. So this is another application of vibration. Okay, next application, that is in stress relieving equipments. Okay, so stress relieving equipments like massagers, right? So these are also useful. Okay, now before studying the vibration, we need to understand certain terms which is useful in study of vibration. First term, that is periodic motion. It is nothing but a motion which repeat itself after equal interval of time. For example, planets are rotating around the sun in elliptical orbits. So the motion of planets, that is periodic because it repeats itself after equal interval of time. For Earth, it is about 365 days, that is periodic time. Okay, then vibrations, that is also in the form of simple harmonic motion, and it is to and fro motion, that is also a periodic motion because it is also repeat itself after equal interval of time. Next one, that is periodic time. Periodic time, that is nothing but time taken to complete one cycle. Okay, that is called periodic time. It is important parameter for vibration analysis. Okay, next one, frequency, that is also most important term in vibration analysis. Okay, frequency, that is number of cycles per unit time. Okay, so in vibratory motion, number of cycles completed per unit time, that is nothing but frequency. Now simple harmonic motion, that is most important because most of cases the vibration in the form of simple harmonic motion. Okay, so simple harmonic motion, that is nothing but a motion of a particle whose acceleration is always directed toward the mean position and is proportional to the distance from the mean position at particular instant of time. So that is the important definition of simple harmonic motion. Okay, it could also be defined as the motion of a projection of particle moving round a circle with uniform angular velocity on a diameter. Now generally this definition is used to derive the equation of motion for simple harmonic motion. Okay, that part we have not discussed here. Okay, next definition, that is amplitude. Now amplitude, that is nothing but the maximum displacement of a vibrating body from the mean position, that is called amplitude. That is another important parameter of vibration analysis. Now next one is free vibration. When no external force is applied after giving it an initial displacement and the body vibrates due to the elastic or internal energy, such vibration is known as free vibration. So as we have discussed earlier, due to the potential energy, due to the conversion of potential energy into kinetic energy and kinetic energy into potential energy, okay, the vibration occurs. So every system having mass and elastic property, they are capable of vibration. Okay, so free vibration, that is nothing but vibration of a body due to the elastic or internal energy of the system. Okay, next one, that is natural frequency. Now natural frequency, that is nothing but the frequency of the free vibration. It means whenever a system is initially deflected by providing some external force, then the body is released. Okay, after releasing the body, if no external force is applied to the system and body continue to vibration due to its elastic or internal energy, the frequency of that vibration is known as natural frequency of system. It could be expressed in radian per second or hertz. So this is most important parameter. Next one, that is forced vibration. So it is the vibration which the system executes under a dynamic external excitation force. Okay, so whenever the system is subjected to dynamic external excitation force, okay, dynamic force, it means its magnitude, direction, or both magnitude and direction is going to change with respect to time. Okay, and due to this kind of force, this system vibrates. That vibration is known as forced vibration. The frequency of vibration in this case is the same that of the external excitation force. It means the frequency of this kind of vibration would be equal to the frequency of applied external excitation force, right? So that part we are going to discuss in detail in the next chapter. Okay, next one, that is damping. Damping is nothing but the resistance provided to the vibratory motion. Okay, it means damping is going to provide the resistance to the vibratory motion. By providing damping, we can control the amplitude of vibration. Okay, next one, resonance. This is the most important phenomenon which has to be avoided while designing any vibratory system. Okay, so whenever the frequency of external excitation force become equal to the natural frequency of the system starts vibrating with maximum amplitude. Okay, and this excessive vibration could even leads to failure of system. So this phenomena is called as resonance, right? So what are the conditions for resonance? That is nothing but when the frequency of external excitation force becomes equal to the natural frequency of the system. So that must be avoided to avoid failure of system, right? So it means the designer should be design any system such that the natural frequency of that system should not lie within the range of external excitation force frequency. It means it should not lie within the working frequency of that system. Okay, that is resonance. Okay, next one, that is fundamental mode of vibration. Fundamental mode of vibration is nothing but the mode having the lowest natural frequency. Okay, so it should be noted that depending on the degree of freedom of the system, we can get number of natural frequencies. For example, for a single degree of freedom, we can have only one natural frequency. If degree of freedom increases, then we can get multiple natural frequencies of the system, and accordingly the mode of vibration would be more. So this part we are going to discuss later. Okay, next one, that is degree of freedom. So we all know that degree of freedom, that is nothing but the minimum number of independent coordinates required to completely specify the motion and the configuration of the system at any instant of time. That is degree of freedom. Okay, so this definition could be better understood by understanding some examples. Here many examples are provided for single degree of freedom system and 2 degree of freedom system. Okay, so in single degree of freedom system, first one, that is simple spring mass system. So here there is only one mass and which is restricted to move in only one direction. So here we can see that it can have rectilinear motion in x direction, right? X is the displacement at any instant of time. So to define the configuration of system at any instant of time, we need to know the value of x. Okay, so the minimum number of coordinates required to completely specify the configuration of system, that is only 1 in this particular case. So that's why the degree of freedom of simple spring mass system is 1. Similar way, here is a simple pendulum. Okay, only this coordinate theta is required to specify the configuration at any instant of time. So that's why its degree of freedom is also 1. Now here in this case, this is a closed mechanism, slider crank mechanism. Okay, and it is having 4 number of parts, but still its number of degree of freedom is 1 because all coordinates are interdependent, like theta, phi or x. Okay, so all these coordinates are interdependent. So it is enough to know the crank angle theta to specify the configuration of this system at any instant of time. So that's why the degree of freedom of slider crank mechanism is 1. Okay, now these are certain examples of 2 degree of freedom system. So first case, that is 2 spring mass system. Okay, here only one mass, but it is supported by 2 springs having different stiffness. Okay, so here what is going to happen, this mass, it could have rectilinear motion. Okay, and it could also having oscillatory motion, angular motion above the center of gravity. Okay, so we need to know both x and theta to get the configuration at any instant of time. So that's why its number of degree of freedom is 2. Okay, next one, that is 2 mass 2 spring system. So here we can see that there are 2 mass m1 and m2 and 2 spring having different stiffness k1 and k2. Okay, here 2 masses having different displacement x and y, which are independent of one another. So that's why we need to know both x and y to get the configuration at particular instant of time. So that's why for this system number of degree of freedom is 2. Now multi-degree of freedom system. So a body in space, it could have maximum 6 number of degree of freedom. Okay, a body in space could have 3 translatory motion, tx, ty and tz, along the all 3 mutually perpendicular axes x, y and z, and it could have rotational motion, or we can say angular motion, rx, ry and rz, about the same 3 mutually perpendicular axes x, y and z. So these are the 6 possible kind of motion of a body in space. So we can say that body in space without any constraint, it is having multi-degree of freedom. Okay, next system, that is infinite degree of freedom. So for that we have taken an example of a flexible beam which is supported at two ends. Okay, so this beam is flexible, so by applying particular loading condition we can bend this system in any shape. So we can get the deflection of this beam such that for particular value of x, the value of y would be different. Okay, and they are independent of each other. So this kind of system is having infinite degree of freedom. Okay, the system having infinite degree of freedom, that is also known as continuous system, or it is also known as distributed system, while the system having finite number of degree of freedom, that is also known as lump system, or we can say discrete system.